This mini lecture is about the trig functions sine, cosine, and tangent. And there's always going to be a theta here. So you'll see them written this way. Sometimes you'll see them written just without the parentheses. But it is good to keep in mind that these are functions. Okay, so how are they defined? They are defined in terms of a right triangle. So let me just give you an example with a 3, 4, 5 right triangle. So let's make this 4 units long, and let's make this 3 units long. So I've got a right angle right here, and then my third side, which would be the hypotenuse, is that side right there. So let's call this side X, and this side Y, and this side H, which is what we'll do in general. So for this particular right triangle, X is equal to 4, Y is equal to 3, and from Pythagoras you should know that H is equal to X squared plus Y squared square root. And so if X was 4, 4 squared, and Y was 3, 3 squared, 4 squared, 16 plus 3 squared, 9 is 25, and H would be equal to 5. So it would be a 3, 4, 5 triangle. So let's call this angle right here the angle between the horizontal and the hypotenuse, theta. The definition of sine is the ratio of y to the hypotenuse, which for this particular triangle is 3 over 5, which is equal to 3 over 5 for this triangle. And the general definition for cosine theta is equal to x over h, which again for this particular triangle is equal to 4 over 5. And finally, the definition for tangent, tan theta, is equal to the ratio of y over x. Now, one of the things we can do with this, with these functions, the sine, cosine, and the tangent, is to if we have x and y, for example, and we want to find the theta with the hypotenuse drawn as it is right now, you can take this equation right here, the tan equation, and if you know what y and x are, you can turn that around and take the inverse function of this, which allows us to say tan theta is equal to tan minus 1 of y over x. And so you can just say tan minus 1 of y over x, or you can say the angle whose tangent is y over x. And if you get your calculator here, I don't know if I have one that's underneath here or not. I don't. But if you just get your calculator and put it into tangent mode, into degree mode, not radian mode, but degree mode, and you type this in. You type in tan minus 1 for this particular triangle of 3 over 4. That will tell you what this angle is. That's one of the tools that we're going to be using here. So I'm going to do that on my calculator, and you should do it on yours. Tan minus 1 of 3 divided by 4 is 36.9 degrees. So I'll write that down. Okay, so that's one of the tools we're going to use. Knowing what the horizontal and vertical legs are in a right triangle, we can find out what the angle between the horizontal leg and the hypotenuse is using this. It's one of the things we're going to use. The other two things we're going to do is, let's say we had this situation where I knew what h was. So here's h, let's say. let's say it's from this same triangle right here, and I knew what theta was, like this, and I wanted to figure out what the horizontal leg of this triangle is. Let me put it in color here so you can see what I'm talking about a little bit better, like that. And what the vertical leg was, like this. By using these definitions for sine theta and for cosine theta. So if I go to the horizontal or the vertical side first, if I know what h and theta is, since sine theta is equal to y over h, this is y here, well, that means that y is equal to h times sine theta. So I can find the vertical side by solving the equation for sine theta for y. And I can do a similar thing for the horizontal red side. So for that, I'll use the definition for cosine theta, which is equal to x over h. And again, I can solve this in a similar fashion for x to get x is equal to h cosine theta. What we're going to see, the segue to vectors, is that we'll think of h as being a vector with a point, let's say, on the top side here. And this would be what's known as the horizontal component of h, a vector now, and y would be the vertical component.